We have the definition of continuity, where f of c exists and the limit as x approaches c of f of x exists, and they are equal to each other. Okay, today we're going to take a little tour into more generalized continuity. Okay, that was very specific at one point. We're just going to identify all the functions that are continuous on their domain, and we could say they're continuous. You can just say p of x is continuous because it's a polynomial.
Are you talking about like paragraphs?
Paragraphs?
The parent graphs.
Oh, parent functions. Yeah, that's exactly what we're doing.
Okay.
Yeah, so last year you knew what the parent functions are.
Yeah.
Okay, so we use that same language. Not really calculus language. And don't forget to put the fun in function.
I thought we were going to escape
I It's the same bet every year. If you can catch me not capitalizing the fun and functions, I will give you a prize. And it's been a couple years.
Yeah, you just haven't.
I don't know yet.
Prizes.
I never have had to come up with one.
Okay.
So, what was the parent functions? We had linear.
Yeah.
You start naming them off.
Y equals x.
Linear, quadratic.
Okay, we have quadratic.
Absolutely.
Okay, this would fall underneath the umbrella of polynomials, right? So we could also do cubics and so on and so forth. All those, right? Those are all continuous. Who said? Somebody said something else.
Absolutely.
Yep.
What's that?
It looks like QBs, not cubics.
Yeah.
It's a pixel problem, not me. What else?
Was the radical one of them?
Yeah, that was so radical. There you go.
Just no.
And now, keep in mind, you have to be careful with this one. This is on its domain. It's continuous. What's the domain of this radical function?
0.
X must be,
0. Oh,
it can be 0. What
One.
else can it be? 1.
Infinite. It has to be great, or it has to be. It can't be a non-negative number, so it's a real number. Oh, yeah.
So on its domain, it's continuous. So be careful there. All right, what else? Do you remember any of the others?
What's the parabola one we can call?
That's
The
this.
parabola is the quadratic. The
About
cubic ones and all that are polynomials.
absolute what? It can. You can do this.
Oh, yeah, you can do the negative on the outside of your absolute value.
Yeah. So yeah, it can. And that, remember, what does that do to the function? Got it. Okay. Is a rational function
No.
always continuous
No. Yes.
on its domain?
Yes.
Yes.
Yeah. Okay. So remember, that's two polynomials and a fraction. Just make sure that this is not going to happen. Right? Okay. What else do we have? Exponential. Right. Log. Oh, you betcha. But don't you know they're so handy for those science careers that you want to go into, like using pH and earthquakes and all that stuff. So there you go. Okay, yeah, logarithms, just remember to be careful. What's the domain of that function? You first saw it last year, so this year you'll probably get it down pat pretty good.
Can you use the domains for every one of them? So like.
Yeah, all these that I'm not mentioning, the domains are real numbers. You can plug anything in there, remember that.
Please dismiss the volleyball girls that are traveling. only today.
Bye, guys.
Go Cardinals.
I thought we were actually gonna have a fire drill there
No,
for a
they're
second.
going to Glen.
Okay,
It's a tournament.
what about
No, I get to stay
this?
here and help tomorrow. I think Kendra might snap.
You gonna go?
No, no, I'm staying here. I'm helping the tournament tomorrow.
Okay.
But I'm still supporting them.
Those, are they continuous on the real line?
Yes.
Yep. The range is very limited, right?
What about tangents, or would that fall under rational?
Good question. Is tangent continuous?
No.
It's not actually, because it's sine over cosine, right?
Right?
Is cosine ever 0?
No. Oh, yes.
Yeah, so the denominator would be 0 as this number
Okay.
is. Okay, I think we're good. Any way that you, so we write our list down. Any way that you combine these, it's still a continuous function, right? Any way you compose these. Remember composition of functions? How do we combine or compose functions? Very carefully. Right?
Yeah.
There's another one. What else? We can subtract them. Yeah. Okay, what else? You said it. Just say it louder. Divide. What's the requirement there? You betcha. And we can multiply as well, right? Okay. Are there any others? Oh, yes, there is. That will be any constant. So any combination of continuous functions makes a continuous function. Okay. So there you go. Oh, we could also do so at this point, now you can say, oh, this is a polynomial, it's continuous. You don't have to really prove it at any point. Unless you're asked to specifically use the definition, you can just generally state any of this is continuous. Okay? We don't have to prove it every time, because there will be times, a lot of the theorems that we use require continuity. Now you can just say, oh, it's a polynomial, it's continuous. Okay, so, I think we're good. Oh, one more. The inverse function is also continuous if the original is continuous. Okay, the star, yippee. So that probably answers a few of the homework questions, right? You can just state that they are continuous now. Yeah, it does. You bet. Any questions?
No. Yeah,
Hi.
can you hold on?
Slow down? Sorry. I'm excited. I'm like tired, but I'm excited because it's calculus. It's awesome.
Did you put the textbook on the classroom?
The textbook is there, but the answer key is not.
Yeah, I don't know.
I haven't uploaded the back end yet.
I was wondering, so I could do it during study hall or my textbook at home.
again, I picked these very specifically, right? So pay attention to those. You are going to have to use the continuity definition still. So don't just make statements. It's continuous. So sometimes you'll be able to say f of x is continuous because polynomials are continuous. Other times you will have to use the definition. Just carry your cards with you for that purpose there. And remember what we did out in the commons. Hopefully that helped. I know. I'm sorry. Might be a little. Was that who said?